All right, let's look at the homework 9.5, problem number 10. All right, so we have a tank with capacity 1,000 liter is full of mixture of water and chlorine, and with a concentration of 0.02 gram per liter. All right. Then, in order to reduce the concentration of chlorine, fresh water is pumped in, so it's the fresh water, and then at the rate of 10 liters per second, and a mixture is stirred and pumped out at the rate of 25 liters per second. Find an amount of chlorine in the tank as a function of time. All right, so let's set up a differential equation. All right, so dy over dt is going to be as before. We have to come up with rate in minus rate out. So rate in and then minus rate out. Alright, so rate out. Alright, so rate in is going to be 0 because fresh water is added. Alright, so rate out, so this is a little bit tricky. So the amount of mixture in the tank could be initially 1,000. Right, but since we're pumping out more than pumping into the tank, the difference is 15 liters per second, which means that it's reducing 50 liters per every second. So we're going to do minus 15 times T. All right, this is going to be the amount of mixture, so that's in liter. All right, then amount of the chlorine in the tank would be Y of T. So Y of T, this is in gram. All right, so here, the concentration is going to be, all right, so you have Y gram out of 1,000 minus 15T. All right, so this is a concentration. Then you would have to multiply by 25, because so minus 25, right? And that's going to be a gram per second. All right, so that's the rate out. So I'm going to write the 25y over 1,000 minus 15t. Alright, so we got that. Then we can, this is a separable equation, so you can use technique from the separable equation, but I'm going to use the integration factor here. Alright, so if you rewrite it, oh actually, sorry, I forgot to do the initial condition. Y sub 0 is going to be, alright, so 0.02 gram per liter times 1,000. Alright, so it's going to be 1, 2, 3, so it's going to be 20. Alright, so let's do this. First equation, I'm going to rewrite it as dy over dt. And move that over to the other side, so it's going to be plus 25 over 1,000 minus 15t. Right, y is equal to 0. Right, so I is going to be, alright, so let's see, maybe I should simplify this a little bit. So everyone is a multiple of 5, so this is going to be 5 divided by 5, so it's 200, and here this is going to be 3. Right, so clean that up. Dy over dt plus 5 over 200 minus 3t y equals 0. Alright, so we have e to the integral, alright, 5 over 200 minus 3t dt. Alright, so this is going to be, let's see, I need to do some adjusting. So I would like to have negative 3. So I'm going to put the 5 outside here. Alright, then so derivative of this is negative 3. So I'm going to put negative 3, but you would have to divide by negative 3. So you would get e to the, alright, constant is negative 5/3. Alright, antiderivative of negative 3 over 200 minus 3t would be natural log of 200 minus 3t. Alright, then this is going to be, we can place this to as a power, so negative 5/3. Then we can cancel e in the natural log, so we get the 200 minus 3t raised to the negative 5/3 power. Alright, so once you have an integrating factor, we know that the solution is y is equal to 1 over I, which is 200 minus 3t to the negative 5/3 power, and integral of q of x is actually 0 times I is going to be 0, so it's a dt. So this is going to be just a number, so it's going to be, alright, so this is going to be c, so I'm going to put c here. Alright, so this is a reciprocal, so it's 200 minus 3t raised to the 5/3 power. Alright, then we can find c by using the initial condition, so consider y of 0. Alright, if you plug in 0, you get the c times 200 to the 5/3 power, and we have to get 20 there. Alright, so if you want to find c, alright, so I'm gonna just divide through by 200 raised to the 5/3 power. So it's going to be c is going to be equal to, let's see, 20 divided by 200 to the 5/3 power. Alright, so therefore we get y of t is equal to, alright, so it's a 20 over 200 raised to the 5/3 power times 200 minus 3t to the 5/3 power. Alright, then actually we can simplify this a little bit, right? So it's going to be 20, I'm going to leave it in here, right? Then I'm going to combine these two guys, so because it's got the 5/3 power, so 200 divided by 200 is going to be 1 minus 3t divided by 200 would be 3 over 200t, then raise it to the 5/3 power. Alright, then let's see, so find the amount of cooling after tank as a function of time. So this is the function that we are looking for. Alright, so let's type it in. Alright, let's see if I can get that. Alright, so we got, Alright, so this is going to be y is equal to, let's see, 20 divided by 1 minus, or actually not divided by times 1 minus 3 over 200 t, maybe I should put t there, raise it to the 5/3 power. Alright, let's submit for testing. Alright, I came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.